Hello all and welcome to the Algebra 1 video for graphing linear equations. And put a little thing in parentheses here. We're specifically looking at graphing linear equations by slope-intercept. Okay, so what this means is we will be looking at equations, and if they are in slope-intercept form, then we have some steps here which we can do to actually graph the equation without need of calculator or really doing any calculations at all. Okay. So how this is going to work is the first step is you do need to write the equation that you have in slope-intercept form if it is not already in slope-intercept form. And I'll show exactly what I mean by that when we look at some of the examples here. Step 2, we need to graph the y-intercept. So if we have the equation in slope-intercept form, the two pieces of information that we get from that are the slope and the y-intercept. So if we know the y-intercept, we can always plot the y-intercept by plotting the point 0b. Okay, and once again, if that's a little confusing, just look at what I do when I do the examples. All this means is once we find what b is, just plot it on the graph. Okay. The next step is to use the slope. So the other piece of information that we have here. So once again, we have slope and y-intercept. So we plotted a point using y-intercept. Well, we find another point or more points by using the slope. Okay, which just to remind everybody is rise over run. And you'll see exactly why I'm reminding you of that when we get to the examples. And then the last part is to use a ruler to draw a line through the points with arrows on both ends. Now, I do have to say that on this, I don't really have a ruler that I can use to draw my straight lines. I'm using a few tricks here of the computer to help me draw some straight lines. But as far as you doing it on your own, basically any straight edge will work. A ruler, in class we use a protractor. You can use the edge of a book, the edge of a phone if it's straight enough. Literally anything that's kind of hard and straight that you can use to draw a straight line. And then that's all you got to do is draw a straight line through the points, and do put arrows on both ends, because that's one thing that we need to realize is these lines actually go on forever and ever and ever. Okay, in both directions that the line goes. So just because there's a limited space on the graph that you're going to be doing doesn't mean that the line actually stops there. So let's jump right into it, and we will look at number 1. Okay, so number 1 here, we have y is equal to negative x plus 5. I am going to do a little bit of a rewrite here just so I can clearly see that this is in slope-intercept form. Y equals mx plus b. So what do I find out about that? Well, I find out the slope is negative 1, and the y-intercept is 5. Now, first things first, we see the y-intercept is 5. So all we're going to do is on the y-axis, we're going to go up to a positive 5. So we're going to go up 1, 2, 3, 4, 5. And that's actually where our first point will go. All right. So our first point is at 0, 5. That's the y-intercept. And then to find the other point, we use the slope. But we notice here that the slope actually isn't a fraction. So that's something that we've got to realize, and you'll see this in number 2 as well, is if your slope isn't a fraction, just put it over 1 to make it into a fraction. So that way you can clearly see, well, what's my rise and what's my run? Well, my rise here is technically going to be negative 1. My run is going to be positive 1. But that's the thing. It's not so important which one's positive, which one's negative as far as rise and run is concerned. What we're concerned about is the whole thing here is actually the slope is negative 1. So when we're wanting to do the find the other point or points, because we can do multiple points here, we've got two options. We can go up or down 1. In this case, some people might see the negative and they say, well, let's go down 1. So that's perfectly fine. You can go down 1. But then we see that the run is 1. and we have to make a choice. We either have to go to the left or to the right one. And in this case, we're going to want to go to the right one because we realize our slope is supposed to be negative. Okay. Now, if we would have went to the left one, you could have seen the resulting line we would have gotten would have been a positive slope line. So here, going to the left or to the right one means that we're going to have a negative lined slope, and that's what we want. So in this case, we want to have a line that goes through both of those points. It's kind of hard to get this right here with this software. It keeps wanting to go sideways, but there we go. It's a little bit easier if you have a ruler and a piece of paper. And there, that'll be, well, this isn't as going quite like I'd liked it to. There we go. It's we'll just try to freehand it then. So once again, you'll go down. This is really hard for me to do on this by freehand in here. I wish this would work a little better. Let's try it one more time. And that's close enough. So our line should look something like this. Now, if you do have a ruler, you can be a little more exact with it. But don't forget to put the arrows, and your line should look something like that. Okay, I do apologize for that right there, but that's the process that you have to go through is plot where the y-intercept is, so plot your b, and then by using the slope, figure out where another point is. Now, we could have did it by going up into the left one as well, and then we could have went down 2 over 2. Okay, so you can see we can get as many points as we need to plot the line, but in reality, you only need 2 points to make a line. So if we look at number 2, same kind of thing. Y equals mx plus b. In this case, my m is going to be -3. My b is going to be -1. So I'm going to go to -1 here. That's where my first point is. My slope is not a fraction, but let me make it into a fraction by just putting it over 1. So that means I need to go up or down 3 and over 1. And we got to realize that the slope is once again negative, so we got to go, let's say we go up 3, 1, 2, 3, then that means we're going to have to go to the left 1 because we want our line to point down because we want negative slope. Same thing, if we go down 3, we're going to want to go to the right 1. And once again, the whole reason that is because we have a negative slope and we need to keep it that way. So in this case, hopefully this one works a little bit better. Yeah, that looks better. So we have a line that looks something like that. Okay, and we could keep going. We can find another point by going up 3 over 1. So we would have this point. And we could get this one, but this one's a little bit harder because we can't actually go off the graph, but we could go down 3 and to the right another one. Okay, so in this case, either way, you should get all the points that you need to make a graph, and your graph should look something like this. Number 3, y equals mx plus b. Okay, so y equals mx plus b. So that means in this case, m is 2/5. B is 2. So that means we're going to go up 2 to the y-intercept. Okay, so that 2 tells us we go here. And then my slope being positive 2/5, that means I'm going to go up or down 2 and to the left or right 5. So once again, it just depends on what we've got going on. So we go up 2, that means we're going to have to go to the right 5. So up 2, 1, 2, 3, 4, 5. So we're going to have this point. We could do it the other way. We could go down 2 and to the left 5. 1, 2, 3, 4, 5. Okay, regardless which way you go, it should still all be on the same line. And in this case, I'm going to start it like right there. And your line should look something, it's a little bit off, but should look something like that. Where once again, I know I needed to go to the right 5 or to the left 5 based on whether I went up or down, because I know I have a positive slope. So I want my line at the end to be pointing up to the right, okay? So that's a big thing to remember here too, is we have negative slope, the line should point down. Negative slope, line should point down. Positive slope, line should point up, okay? And that's pretty much it for the technique. Now, we are going to get into some examples going forward here where you might not have your equation in slope-intercept form, but we'll discuss on how to do that when we come to it. But as we go on to numbers 4, 5, and 6, same exact thing. Y equals mx plus b. Y equals, so my slope here is negative 1/4. My b is 3. So in this case, I'm going to go up 1, 2, 3. And then my slope is negative 1/4, so that means I'm going to go up or down. So rise is 1, run is 4. So I'm going to go up 1 over 4, but I've got to be careful. If I go up 1, I'm going to have to go to the left 4. 1, 2, 3, 4. If I go down 1, then I've got to go to the right 4. 1, 2, 3, 4. But regardless which way that I go, you can see all these points fall on the same line. So if we graph this, okay, if we graph this, you should get a line that looks something like this. Where once again, I know that which way I need to go in terms of up or down or left or right is given to me by the slope being negative in this case. So if I go up 1, I have to go to the left 4. If I would have went to the right 4, I would have gotten a positive slope. Okay, and that's pretty much all there is to it. Y equals mx plus b. So m is 2 over 1. B is 6, so I go up 6. 1, 2, 3, 4, 5, 6. That's very up here, all the way up here at the top. In this case, we're kind of forced. We have to go down 2 and over 1. So that means I've got to go down 2, but then I've got to think, well, in this case, I need a positive 2 slope, so I'm going to have to go to the left. Where, once again, if I plot those 2 points, which I can go another one, I can go here. I can go down 2 over 1 here. So regardless, I should get all these points on the same line. Okay, let me make this a little better. So our line should look something like that. Not perfect without having a straight edge here, but should look something like that. But once again, we know it should look like that because this is a positive slope. Y equals mx plus b. Well, in this case, we've got m is negative 3/2. B is negative 5. So we're going to go down 5. 1, 2, 3, 4, 5. And here we've got to go up or down 3. Well, in this case, we're kind of forced to go up 3 and then over 2. So 1, 2, 3. And then we need a negative slope, so 1, 2. We're going to go to the left. Up 3, 1, 2, 3, over 2. Up 3, over 2. So you can kind of see every single one of these points will fall on the same line. So if we graph these, we get a line that kind of looks like that. Okay. And once again, all this stems from being able to find where the y-intercept is. Okay, so plotting the y-intercept and then using the slope to find what the other with the slope tells us whether we need to go up or down, left or right. And then sometimes, like with this one, we had to go up 3. We couldn't go down 3 because that would take us off our graph. So just be aware of that. It may happen sometimes if your y-intercept is close to one of the tops or bottoms of the graph. All right, so number 7. We look at this one and it looks like, well, maybe that's not in slope-intercept form, because if we look at y equals mx plus b, we have y equals mx, but where's the plus b? Okay, and this just goes in general for any question like this, that if you have y is equal to an x term, you can always slap a plus 0 on there, and then now you can see, well, my slope is negative 4 over 1, and my y-intercept in this case is actually 0. Well, what that means in terms of our graph is that means our graph is actually going to cross through the origin. It's going to cross through right there. So that's our first point, is actually the origin. And then we take the slope, just like we would any other time, and count up or down 4 and over 1. So in this case, I'm going to count up 1, 2, 3, 4. I've got to go to the left 1 this time because we need a negative slope. Same thing. If I go down 4, 1, 2, 3, 4, I'm going to have to go to the right 1 because, once again, I need a negative slope. And just like always here, just connect our 3 points that we get, or 2, just 2 if you only did 2. Because really all you need to graph an equation is 2 points. And there you have it. Okay, you have the graph of the equation. Now then we get to number 8, and we need y equals mx plus b. But if you look here, we have y equals, well, there's no x with the negative 3, and the 5 has an x. So what we have to do with this one is we have to flip our equation around in order to get it into y equals mx plus b form. So that way we can clearly see, well, the slope here is going to be 5 over 1, and my y-intercept would be negative 3. Okay, you can kind of tell from this up here, you can kind of think, well, what's the number beside the x? Well, if it's in y equals form, your slope's always going to be the number directly next to the x. So in this case, it'd be a positive 5. And then the y-intercept is the constant term. In this case, would be negative 3. So we would go negative 3, so down 3 to right here. Up 5 or down 5. In this case, we're kind of forced to go up 5. So up 5, 1, 2, 3, 4, 5, and to the right 1. Once again, I have to go right there because if I went left, I would have a negative slope. And then we could actually do it again if we had enough space, but what we would want to do is go up 1, 2, 3, 4, 5, and then over 1. So we can only fit 2 lines or 2 points on this graph. But once again, you go through, make a line to go through both of those points. Oops. And there's what your line should look like. Something like that. Now, it doesn't have to be exact when you're doing it by hand, okay? But you do need to recognize a few different things here, like the 2 points that I got. I got the point 0, negative 3, and the point 1, 2, okay? And as long as you know those 2 points, that'll allow you to know what the slope is, what the y-intercept is, and pretty much anything else that you needed to know, because then you could just plot those 2 points and graph, okay? And the same thing is going to happen with number 9. Okay, y equals mx plus b. Well, things are kind of flipped around here, but we can still kind of see that my slope is going to be negative 6/5. my y-intercept here would be a positive 1. So that means I'm going to start here at positive 1 on the y, go up or down 6, and then left or right 5. So I'm going to go up 6, 1, 2, 3, 4, 5. Well, I actually can't do that. So I'm kind of forced. I got to go down 6. 1, 2, 3, 4, 5, 6. And in this case, that means I need to go to the right 5. 1, 2, 3, 4, 5. Okay, so there's actually my 2 points. And just like always, we get at least 2 points. We would be able to do another one up here, okay, if we could, but we can't go up 6. So we kind of have to deal with what we've got here. So this one's a little tricky. We have to go 6, so 6 over 5. So we're somewhere like right here. Let me just... Once again, it's not going to be perfect. Neither is yours when you use a protractor or a ruler. It's not going to be 100% perfect, but you should at least have the general shape of what the graph looks like here, which once again tells us our y-intercept is 1. And then if you calculate the slope from one point to the other, you'll find that it's negative 6 over 5. Okay. Like I said, every single one of these works the same, even when we get to numbers 10 through 17. Okay. So starting with number 10, you notice our equation isn't in y equals mx plus b form. So our equation isn't in slope-intercept form. So here's where we have to rely on what we were able to do in the last section, which is convert something in standard form to slope-intercept form. Okay, and I'm going to go over this a little bit quicker than I normally would, considering this is what we did in the last section. Okay, but at the same time, this is something that a lot of people do need to practice with, because this is one of the tougher things to know how to do in algebra, which is, in our case, solve for y. So we want to solve this equation for y. Well, what do? That means the first step means we're going to have to take away our x term. And we want to do that to get 3y over here by itself. And what do we have on the other side? Well, we have negative 3 minus 1x. Okay, and we can't just add or subtract these numbers together because we don't know what x is. Okay, and as long as we don't know what x is, we can't just add it or subtract it to negative 3 or from negative 3. So in this case, we just leave it like it's written, negative 3 minus 1x. So we rewrite it once again. So in this case, same as like we did before, I'm going to take my terms and I'm going to flip them around here. So negative 1x minus 3. So what I end up having to do here is divide by 3. Okay, and notice when I divide by 3, that makes those 3 go away. So we have y is equal to. And then notice when I divided by 3 over here, I just did it times to each number. So divide negative 1 by 3 to give me negative 1/3 x minus 3 over 3, so minus 1. And now that I have my graph in slope-intercept form, now I can go and graph. So it would be at negative 1. So y-intercept is negative 1. I need to go up 1 and over 3. So I have to go, if I go up 1, I have to go to the left 3. If I go down 1, then I have to go to the right 3. And I can actually keep making points this way. Down 2, 3. Down. Well, I can't go any further there, but then I go up 1, 1, 2, 3. And there we go. All of those points should stay on the same line, where once again, connect them all together. Once again, not exactly perfect, but your line should look something like that. And I do want to point out to you here is you do have Desmos Calculator you can use. So just to show you really quickly, I'm going to plot both of these lines. So we have x plus 3y equals negative 3. So x plus 3y equals negative 3. And then what was the other one? Well, the other one that we solved for was y is equal to negative 1/3 x minus 1. So y is equal to negative 1/3 x minus 1. And if you notice, Both of those lines are exactly the same. So if you plot the red one and the blue one covers up the red one, or vice versa. You plot the red one, which you can move it so that way you can plot the red one over the blue one. Okay. But the point I'm trying to make here is at the end, once you figure out what your slope is, your equation is in slope-intercept form, graph both of them and see if it doesn't give you the same line. If it doesn't, that means you've done something wrong and this equation is not the same as this equation. Okay? So what you've really got to do there is make sure when you graph both of these lines that they are in fact the same. And like I said, you can move them around here so you can cover up the red one with the blue one or vice versa. Okay, so like I said, what should happen here is both of your equations should graph you the same line. Okay, and then you can actually go through and find points and make sure the points match up. So in this case, 0, -1, 0, -1. We should have the point -3, 0. Well, is the point -3, 0 on here? -3, 0. There it is. Okay, so these lines and these two equations are exactly the same. And you can actually do that with any of these. Okay, Desmos allows you to graph any equation as long as you type it in correctly. So when we look at this one, number 11, we can graph x minus y equals -5. So let me clear the rest of these off. So we have x minus y equals -5. So that's the line we should get. Now, how technically should we do that if we're doing it by hand? Well, we should find what our equation is as slope-intercept form. Meaning, we go through, in this case, these are both 1, so 1x, 1y. So we have 1x minus 1y. So that means same thing we did over here. We're going to subtract or add. In our case, we're going to get rid of the x term, however we have to. So we have -1y is equal to -5 minus 1x. That leads me to write -1y is equal to -1x minus 5. So once again, all I'm doing is I'm taking my x term and taking my constant term and switching them around. So -1x, -5, so minus 5. Then we would divide by -1. So in this case, the -1's go away, so we get y is equal to -1 over -1 is a positive 1x. And you can think of it as a -5, since b is -5. -5 divided by -1, which is a positive 5. And that's actually my equation written in slope-intercept form. Y equals mx plus b. So my graph is go up 5. 1, 2, 3, 4, 5. My slope is 1 over 1. And you can actually write it down here like you did before. 1 over 1. My b is 5. So then I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. Okay. And then you could go down 1 over 1. So down 1, left 1. Down 1, left 1. Down 1, left 1. And you can keep going with that, and you can see all of these points should be on the same line. So your line should look like this. Where once again, you can see what the y-intercept is right here, and our slope is 1. Well, once again, if we're unsure, graph both of those equations. We already did the 1x minus 1y, so x minus y equals -5. So now let's do y is equal to 1x plus 5, or x plus 5. So y is equal to x plus 5. And you get the actual same thing. We got the green line is covered up by the, I guess it's a purple line, okay? And vice versa. If we flip it around, the purple line can be covered up by the green line, whichever way, okay? But all that tells you is both of these equations are the same, meaning you solve for y correctly, meaning you have it in slope-intercept form now, okay? So use that, and once again, all the rest of these work exactly the same. So we're going to rush through them a little bit quicker. So if you wanted to, practice with these, try these out, and see if you can't get the same thing I do. So if you did want to pause the video, try these out on your own, and then come back and check yourself. That's something you can do. So same thing here. We're going to subtract 5x. So what do we get? We get negative 1y, because these will go away, is equal to negative 3 minus 5x. We flip these terms around, so we get negative 5x minus 3. And now we just divide by what's in front of the y. So divide by negative 1. So the negative 1's go away, so we get y is equal to negative 5 over negative 1 is a positive 5. X, negative 3 over negative 1 is a positive 3. And there we go. So we go up 3. Once again, we can write it out down here. So 5 over 1, b is 1, or in this case 3. So that's why we go up 3. Then we have to go up 5 over 1 or down 5 over 1. So up 5, 1, 2, 3, 4, 5 over 1. We need it positive, so there we go. And then down 5, 1, 2, 3, 4, 5, and over 1. And there you have it. So it should look something like this. And we can verify that. We can check it, because let's just plot both of these points, or plot both of these equations. So 5x minus y equals negative 3. 5x minus y equals negative 3. And then what was the other one? Y equals 5x plus 3. Y equals 5x plus 3. Same thing. So we have black line is the original equation. Red line is the y equals version. And both of them are the same. So that means both of my equations are correct in that. And also I have my graph correct, because if you look, you can find the points that are there. 0, 3, negative 1, negative 2. Well, 0, 3, negative 1. So negative 1 is right here, negative 2 right there. It's hard to get it right on. There we go. Okay. So once again, all these work the same in that regard, is that in that you can actually check your work by just using Desmos and plotting the graph. Same thing here. Let me go ahead and graph it. So 4x plus 3y equals 21. 4x plus 3y equals 21. So my line should look something like this. So notice it should have negative slope. Well, we go back. Let's solve this for y. Subtract 4x. We get 3y is equal to 21 minus 4x. 3y is equal to negative 4x plus 21. Divide by 3. So we got to do it to both terms over here. Y is equal to negative 4/3 x plus 7. Or once again, that means my slope is negative 4/3. My b is 7. And those are the two pieces of information that I need. Okay. But just to double check and make sure I did this correctly, I graphed this. Now let's go ahead and graph y equals negative 4/3 x plus 7. Y equals negative 4/3 x plus 7. And when you know it, same exact line again. Okay, so that's a good sign, meaning we have solved our equation correctly for y. Okay, so now just a matter of plotting the points here. So go up 7, 1, 2, 3, 4, 5, 6, 7 in this case right here. And then we can either go up or down. In this case, we're forced to go down 4 and then left or right 3. So we need to go down 4, 1, 2, 3, 4. In this case, we're going to have to go to the right 3, 1, 2, 3. And then we can actually do that again. Down 1, 2, 3, 4 over 1, 2, 3. But we have to go to the left or to the right here because we need our line to have negative slope. So it's going to look something like this. Once again, it's not going to be perfect. But you can verify and say, well, look at this one versus what we just did. Looks pretty good to me. Let's hide that again. So once again, looks pretty good to me. Okay, and if all else fails, just look at some points that are here. Okay, what's this point that's right here? 1, 2, 3, 1, 2, 3. So I have the point 3, 3. Well, is the point 3, 3 on there? 1. So it's kind of weird here. You got 1, 2, 3, 1, 2, 3. Yep. So point 3, 3 right there. Okay. And you can check any other points that you want to, but these two are, in fact, the same line. All right, so getting close to the end here, so just 4 more, but same exact steps. We're going to subtract 2x. Negative 4y is equal to, I'm going to take a shortcut here, see if you can catch what I've done. I went ahead and took my x term and flipped it around with my constant term. So now all I've got to do is divide by negative 4. So what do we get here? We get y is equal to negative over negative. That's positive. It'll reduce to 1/2 x. Positive 20 over negative 4, negative 5. So minus 5. And there's my equation. Okay. But as always, if you need to, just double check yourself. 2x minus 4y equals 20. 2x minus 4y equals 20. And then we had y equals 1/2 x minus 5. Y equals 1/2 x minus 5. There you have it. Okay, both lines are exactly the same. You can see one just goes over the other, which tells us that this equation is correct. And then we just go through and figure out what we've got. We've got m is 1/2, b is negative 5. So we're going to go down 5. 1, 2, 3, 4, 5. And then we have to go up 1 and over 2. So up 1 over to the right 2. Or we can go down 1 and to the left 2. Then we can keep doing that. Okay, to get as many points as we need, and then it's just a matter of connecting them all together, and there's your line. Okay, which once again, double check with the line that you have. That looks pretty similar to me. And if you go through and check, well, look at these different points. We have the point 2, 1, 2, 3, 4. So 2, negative 4. 2, negative 4. And let's look at this point. We have the point 1, 2, 3, 4. So 4, 1, 2, 3. So negative 3. Well, are those points on the original graph or on the actual graph? So what did we say? 2, negative 4. 2, negative 4 right there. And we have the point 3. 4, negative 3. Okay. So as long as 2 points are correct, then that means the whole line's correct, because then you can just, you could actually go and check all the rest of these, but as long as 2 points that are on the line that you have, that means it's right. Number 15, this one's a little tricky, so let's go ahead and graph it first. 2x plus 3y equals 0. 2x plus 3y equals 0. So that's our line. Notice it goes through the origin, 0.00. So when we solve this, we should get a y-intercept of 0. Well, let's go through and actually do this. So subtract 2x, subtract 2x. We get 3y is equal to, well, 0 minus 2x. We can actually calculate that. 0 minus 2x will just give us negative 2x. And then we divide by 3. Y is equal to negative 2/3 x. And we can verify that by going over here and saying y is equal to negative 2/3 x. You can see the blue line covers up the red line, so that means both of these equations are the exact same equation, meaning if we graph this one, where our slope is negative 2/3 and our b in this case is actually 0, so that tells us we're right in the middle, and then negative 2/3, so that means we need to go up 2 and then to the left 3, or down 2 and to the right 3. Down 2, right 3. It's right there. Up 2, 1, 2, 3, there. And once again, you can fill in as many points as you want to, but technically you only need 2. But then when you do that, you get, so up 2 over 3, so it would be somewhere like right there. Connect all our points, and we get a graph that looks something like that. Okay, and you can verify by just looking back at the other graph. That looks pretty good to me. Okay, but as always, you can pick some points. So we have the point 0, 0 there. Well, we obviously have the point 0, 0 here. Well, pick another point. Let's do 3, negative 2. Was the point 3, negative 2 on our graph? Well, 3 is right here. Negative 2 is right here. So that's the point right there. 3, negative 2. Now that both of those points are on there, that means our graph is correct. Okay. And then the last two should be pretty straightforward. Same kind of idea here. We're going to subtract the x term, or get rid of the x term. Sometimes you might have to add the x term, depending on if your x term is negative. But here we get negative 8y is equal to negative 10x plus 24. So let me scoot that over a little bit. So negative 8y is equal to negative 10x plus 24. Then we divide by negative 8. So we get y is equal to, negative over negative is a positive. This reduces down, though, to 5/4 x. And then positive 24 over negative 8, that's a negative 3. And just to show you that these are, in fact, the same, just 10x minus 8y equals 24. So 10x minus 8y equals 24. So there's that line. Then the other one we had was 5/4 x minus 3. So y equals 5/4 x minus 3. Once again, if you solved it correctly, both of those lines should be the same, should plot the same line. Both of those equations should plot the same line. Okay, so just plot this. We go down 3 right there. Up 5 over 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Could go down 5. 1, 2, 3, 4, 5 over 1, 2, 3, 4. But once again, you need to make sure that your line has a positive slope here. So it's a positive 5/4. So then we go through. That's going to give us our line that looks like this. So we could have did it again. We could have did up 5, 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So we could have had this point right here. But we see that anyways, because if we do our lines, everything works out. And then you can check your lines to see if that's not the same. And once again, you can check it point by point. So you can check the point here, 0, negative 3. You can check the point here, 1, 2, 3, 4, 2. You can check the point all the way up here if you wanted to. That's 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. So that's 8, 7. But really, you only need to check 2 of those points, because if those 2 are on there, then that means your line is 100% correct. And then the last one here, minus 9x minus 9x. So we get 12y is equal to negative 9x plus 12. Divide by 12, divide by 12, divide by 12. Y is equal to negative 3/4 x plus 1. You might be wondering, where did I get negative 3/4 here? Well, negative over positive is a negative. 9 divided by 12, that reduces to 3/4. And just to show you, you can do that really, really easily here with Desmos as well. Negative 9 over 12, well, that reduces down. The simplest version of that is negative 3/4. And that's what we need when we do slope-intercept form, is we need the simplest version. So that means our graph should look like this. We go up 1. So there's our first point. And then we can go, let's say we go up 3. So 1, 2, 3. We're going to have to go to the left 4. 3, 4. So we have a point right there. We also have a point if we go down 3. 1, 2, 3 over 1, 2, 3, 4. And we can actually do it again if we wanted to. Down 1, 2, 3. 1, 2, 3, 4. And actually, we can do it again up here, I think. 1, 2, 3. 1, 2, 3, 4. Yep. So we could plot a total of 5 different points on that graph if we wanted to, but really we only need 2. And if you do get those, then you connect them all here. That's what our line should look like. Something like that, which you can verify by going over here. So we have 9x plus 12y equals 12. 9x plus 12y equals 12. So there's that line. And then the other one we had was y equals negative 3/4 x plus 1, which looks completely different, but watch this. Y equals negative 3/4 x plus 1. Again, it looks kind of weird that it's this way, but look at what we have. We have the same exact line. The blue covers up the red. That means our equation is correct, and that means our graph matches up. And once again, you can just check by looking up some points. So we have the point 0, 1. We have the point 1, 2, 3, 4, negative 2. We have the point 1, 2, 3, 4, 1, 2, 3, 4. So negative 4, 4. And you can verify by going through and checking each point. If you really had to make sure you had the right line, is go through. Well, there's negative 4, 4. Here's the point 0, 1. Here's the point 2. Well, in this case, we don't want to do 2. You want to do 2 or 4, negative 2. Okay. But like I said, just check and make sure your points are correct. If you do that, then you should be able to graph it correctly. But I do want everybody to practice with. So please practice with solving for y. It's a very good skill to have in algebra. So if nothing else, if you get all the graphs down, you can actually do all the graphs by using Desmos if you really wanted to. But at the same time, it's still good practice to go through and solve for y. So put it in y equals mx plus b form. And then you can actually graph any linear equation that you have by hand if you have it in this form. Okay. So with that being said, that's all for this section. Now, next section we'll be graphing some more, but I'm going to be talking about other techniques we can use to graph equations. But other than that, go through here, practice with these, do the homework. And as always, thank you for watching.